This is pretty snazzy. This is a good way to, this is how people might have figured out square roots before there were calculators. It works pretty well. Now the hardest part here, well obviously it's easy to write this formula in your cheat sheet. The hardest part is coming up with f. The hard part is coming up with the right function. You need a function whose root is the answer you're going for. So let's do another example. Suppose you were trying to figure out the square root of 38. What function would you use?
X squared minus 38.
And how do you know? Because if you plug in root 38 into this function, it comes out to be 0. And that's what you're going for. You're going for a function where if you plug in the number you're looking for, it comes out to be 0. So that's good. Let's do a harder case. And a good first guess here would be 6, because obviously 6 squared is 36. Suppose that you're trying to do the cube root of 30. What would be a good function?
X to the third minus 3.
Now let's make sure that this really would be a root. If I plugged in this number into here, well, the cube root of 30 cubed would be 30. So this would come out to be 0. So that's right. This is the right function to use in this case. So you can use this for any type of root, not just square roots. Okay? All right, good. So the method here is come up with the f function whose root is the number that you're going for, and then plug into this formula. In this case, probably a good first guess would be 3, because 3 cubed is 27, and that's about as close as we're going to get to here. All right. Number 9. Have you tried this one already? Okay, well, any ideas about how you would get started?
I don't know if you're supposed to not simplify, but manipulate it.
Mm-hmm. Yeah, that's one method that would work. That's right. So that's a good start.
I don't know how you deal with anything that has more than one function.
So one thing that you should put in your cheat sheet, if you haven't memorized it, is the definitions of tangent and secant. So it looks like you know that this is the same as tangent, and this is the same as secant. Okay, and now you're almost done, actually. Now, if this method didn't work for you, there is another method you could have used. But this method actually would work very nicely. What we're trying to do here is find an antiderivative, right? That is, we want to know what function has the. We want to find a function whose derivative is this. A function whose derivative is this. Well, there actually is a trig function whose derivative is this, and that should be in your cheat sheet. If you have in your cheat sheet, you should have all the derivatives in there. What trig function has a derivative that's this?
Was it secant squared actually? Or tangent squared?
Yeah, do you have your cheat sheet made up?
No,
Or?
I don't.
All right, so, well, let's review those. So what's the derivative of the sine?
Cosine.
And what's the derivative of the cosine?
Negative sine.
What's the derivative of the tangent? Oh, that maybe it's one that you know now.
Secant squared.
Good. And what's the derivative of the secant?
Tangent.
That's right. The derivative of the secant is the tangent times the secant.
Can you show how we would go about it if we didn't know that?
Sure.
From the sine?
All right, so it sounds like you're just ready to declare victory here. What's the answer?
Oh, secant x, or secant theta.
Like this?
Plus c.
Yeah, plus c. Right. So we just saw that's right. We just saw that this is the antiderivative of this.
Every time you take away the integral.
This just means take the antiderivative of this function. That is, we want to find something whose derivative is this. Well, we just saw that secant is the function whose derivative is this. So this is one good way to do antiderivatives involving trig functions. One good way to do antiderivatives involving trig functions is just rearrange it until it looks like one of the derivatives you already know. Well, here we were able to rearrange this into something that we knew was the derivative of something else. And then we were able to say what its antiderivative is. All right, so these are all important things to have in your cheat sheets. Okay. Does that make sense? Now, the other method here is to use the substitution method. Any guesses what substitution we might use?
Cosine squared, or
That's right. Now, how do you use the substitution method? Well, you have to figure out what du is. So what would du be here?
negative sign.
Like this? Now, that's not quite right. You'd have to write with the d theta. For me, the easiest way to do that is to figure out the derivative of u with respect to theta. Well, the derivative of u with respect to theta is negative sine theta, and then I solve this for du. I treat d theta like it's an independent variable, so we can multiply both sides by d theta, and that's how we figure out what this differential is. So one good way to figure out a differential is just to find the derivative, and then move one of the differentials to the other side. So we end up with this. But this is not a minor afterthought, this is key, so we have to include this. What we want to do here is we want to simplify this formula. We want to simplify this by substituting things out. So I'm going to rewrite this. This formula doesn't have a negative sign, so I'm going to get the negative sign off of the right-hand side. And now I can make simplifications. So what am I going to plug in for 1 over cosine squared theta? Well, that becomes 1 over u squared. And what am I going to plug in for sine theta d theta? Well, that's what all this work was doing over here to figure out what to plug in for sine theta d theta. Well, that's going to be negative du. We can take the negative sign out of antiderivative.
I'm a little confused
Okay.
on what you did.
Well, which step is the one that's...
Like I understood that the first like du, but now I don't understand that yet.
All right, so let's see. This is what we were given. This is just rewriting this. So going from here to here, is this the difficulty? So what we're doing here is we're plugging in u for cosine theta.
Right.
Well, if I plug in u for cosine theta, 1 over cosine squared is just 1 over u squared. And we're plugging in negative du for sine theta d theta. So we've set ourselves up to make two simplifying simplifications. I plugged in u for cosine theta, which makes this term into this. And I plugged in negative du for sine theta d theta, which makes this term into this. How do I know that I'm doing a good job? Because this is much simpler than what I had before. What we want to do is make substitutions that will make the integral much simpler than it was before.
Okay.
If it wasn't getting simpler, I would go back and try a different substitution. So you basically have to do trial and error until you get a substitution that gives you a solvable integral.